Hello out there to you. In this clip, let's go over graphically what's going on with a monopoly graph, how to solve for profit maximization, total cost, so on and so forth. Okay, and I'm looking at the numbers here. I have a pretty good number that we can use. However, going from here to here, that would be about 50, so we'll call that 48. Okay, that number will be important in a second or so. Okay, so if you're asked to do profit maximization and you see this this kind of graph here, you know that it's a monopoly because we've got a demand curve and then marginal revenue. Marginal revenue represents the rate of change in total revenue. So if you're doing a calculus-based class, it's the partial derivative with respect to Q of the total revenue function. If you're not, that's okay. So we've got this demand curve here. This is the willingness to pay by all the consumers. So if we want profit maximization, it's often written as pi and then maximization. We want to produce to where the marginal revenue equals marginal cost. Okay, so where that happens, we are profit maximizing. So let's just follow marginal cost. I'll do it in yellow here. We're going to go up here. And that's where marginal cost hits marginal revenue. So it's at point E, and it's at quantity 48. So the quantity is 48. However, this firm has some kind of pricing power. They can charge a higher price and sell 48 units. So we're going to follow that up to here, up to point B. And so the price, profit maximizing price, we'll call that PM for price of monopoly or profit maximization, whatever, is going to be 11. So our total revenue, when we're profit maximizing, total revenue is price times quantity. So that would be 48 times 11, and I don't know what that is, and I didn't load a calculator ahead of time. Geez, 48 times 11 is 528. 528. So that's my total revenue. Now it's not profit because profit we have to use whatever the average cost is here, right? So you got a couple of options. One, you can just calculate whatever the total cost is. So total cost is going to be found by getting the average total cost times the quantity. So we know that. So we're going to produce 48 units, and on average it's going to cost us 6 to produce 48 units. So we can do 48, that in there, times 6, 48 times 6. Am I supposed to know what that is in my head? No. That's 288. Okay, so 288 is the total cost. So profit, total profit is going to be total revenue minus total cost. So it's this minus this. So 528 minus 288, and that would be 240. So total profit is going to be 240. Now, alternatively, you could also calculate, if you were just looking at the graph here, we know we're going to produce this many units, and we know that this is going to be our total revenue. So if we follow this down to where it hits total cost, this rectangle here, this red rectangle, also represents profit. So you could calculate the difference between here and here, which is 11 to 6 is 5, and then 5 times 48, I'll bet it's going to be the same. It's 240. So you could also do that. Okay. Or you could say to yourself, I suppose, how much profit per unit am I going to earn? Okay, so that would be the difference between 6 and 5, or 6 and 11, which is 5. And then multiply that by 48, you'd get the same answer. So that would work too. You get multiple ways to do that. Now, this is the monopoly outcome, right? They're going to produce 48 units. They're going to cost 11. Now, that's different than the competitive outcome. So sometimes this will be referred to as allocatively efficient. And that's point C right there. So what that means is if this market was competitive, marginal cost would equal demand. And so we'd actually have more units produced. So this right here is the loss in efficiency due to this monopoly. So this is the deadweight loss. So if I was just looking at letters, it's B, C, E. If I want to do numbers, it's from 7 to 11, which is 4. Because this is just a, I mean, I guess it's almost a linear triangle. We can fudge that a little bit, but it's, so if it was linear, it'd be 11 to 11 down to 7, which is 4. And then we'll multiply that by the number of lost units, which is 12. Okay, 12 times 4, and then 24. Okay, probably should have known that in my head, but you know, whatever. Been out in the sun today. Okay, so that's 48. That's the area of that right there. And just in case you're asked about productive efficiency, that's productive efficiency. That's the cheapest. And if they say something about a fair use price, then that's going to be right there. That's where its firm is breaking even. So that would be at 8. That's where average total cost equals demand. Okay, so that's what's going on with demand curve and a monopoly. If you just have a little graph there and how to analyze all of that.